Today we'll learn about the difference between something called a common log and something called a natural log. We've been working with logs of all different bases so far. You've seen variables in the bases, you've seen other numbers in the bases. Now we're going to focus our attention on two special logs. One of them is called a common log and one of them is called a natural log. The common log, as you might have guessed, is a log that has a base 10. You can think of common with the O in it and the word log with the O in it. Base 10 with the O in it, if you want to think of it that way, to help you keep the two of them straight. And we have something called a natural log. A natural log is usually written with just a little ln, and oftentimes it's italicized ln. But what it is the equivalent of a log with a base of e. E is a new number that we saw in the last unit. It's an irrational number, so the only way we can represent it exactly is by using that script letter E. And you will have buttons for both the common logs and the natural logs on your calculator, depending on which one you need to use. All of the laws that we learned about logs in general apply to common logs. They also apply it with natural logs, so you don't have to learn a new set of laws. All the expansion and contraction works the same way. All the going back and forth works the same way, but the back and forth we'd want to be thinking about it in this form here. Then we're going to talk about what happens when we find something called antilogs. Now, if you write out an expression in logarithmic form, if I write out log base 10 of, let's see, 100 is equal to 2, then 100 is called the antilog of 2. So the antilog is in the argument, and likewise we can do the same thing with the natural logs. So if I take 10 and I square it, I get 100. 100 is the common antilog of 2. If I take constant e and I square it, I raise it to the second power, I get about 7.39. It's irrational, so we'll just round it off. Then I say 7.39 is the natural antilog of 2. So the number that appears in the argument would be the antilog when you set it up with that logarithmic form. Okay, if log of 279, and again I'm going to make an assumption here. I'm making an assumption of base 10. It's a common log even though you don't see it written. So log 279 is equals 2.45. Then that tells me that 10 to the 2.45 is equal to 279, and I say that 279 is the antilog of that long irrational number. And again, calculator buttons available to you when you need them. We'll be getting some good calculator practice today. I can do the same thing with the natural logs. If the natural log of 279 is equal to 5.6, then when I take e and I raise it to the 5.6 power, I get 279. We say that 279 is the natural antilog of 5.63. Let's go to some examples from your homework. First section will ask you just to evaluate. Evaluating is a simple matter of plugging it into the calculator and choosing the right calculator buttons. Shouldn't be difficult. So we'll choose control, and then the common log is right next to the 1 there. That'll open the two boxes, and the only thing you're allowed to type in that lower box is a 10. If you try to type anything else, it's not going to work. So we'll just leave that blank. You can type the 10 if you feel like it, and I'll type a 0.002 into the argument. We see an answer of 2.69897. I'm going to write that down. Minus 2.6989, and I have rounding instructions to the nearest hundredth. So the way that rounding works, if I am going to round this up and it's 2.7, remember 5789 will go 56789 will go up. 0, 1, 2, 3, 4 you'll drop off, so this one's going to have to go up. We have to include the 0 there. When you round that off to the nearest hundredth, you must have 2 decimal digits, even if some of the ones on the end are 0. On the next one, I'm finding the antilog, and it's telling you the antilog is the argument. But if it says find the antilog, well, that's usually going to be the variable that's or the variable in the problem. So we can turn this around. We can say that 10 to the 2.2030 is equal to x, and now you can use your antilog button, which is right under the log. We're working with common log, so escape out of that. escape out of anything when you're somewhere you don't want to be. And let's do a 10 to the x and just type in that 2.2030. Hit the enter key, write down an unrounded number first. I always like to have unrounded numbers, and that tells us whether you made a rounding error or whether you made some other kind of error. 159.5879. If I need to go to the 4 decimal places here, then I don't have enough yet. I'm going to grab the 1 and the 4. And now to go to 4 decimal places, I'll just drop it because it's a 1. My answer will be 159.5879. In the third one on this page, this is a little bit different version. You're not evaluating, you're not using the calculator for these. In these, what's happening is you're given a substitution. You're told that log of 3 equals x and log of 5 equals y. So your goal in these kinds of problems is to take this expression and try to write it so that it comes up to be a combination of log 3's and or log 5's. Well, log 25 is the same as log of 5 times 5. Simple change there in the argument. And now I can use my laws of expansion to say that's the same as the log of 5 plus the log of 5. And I have a substitution for the log of 5. It means the same thing as y. So I'll change this to a y. I'll change this to a y. Put that plus sign in the middle. My answer becomes 2y. Same thing down the bottom here. I have an expression for log of a. I don't have any other expressions, so I'm going to have to do something with this in order to put it in terms of log of a, and we'll see what else happens. If this is log of 10 times a, then when I expand it becomes the log of 10 plus the log of a. I have an exchange for the log of a. I can put c right there, so this whole thing becomes a c. And I don't have any replacement for log of 10, but if you rewrite log of 10, what you're writing here is 10 to the x equal 10, and that should be easy enough for you to figure out that that whole thing evaluates to a 1. So my answer here is 1 plus c. Another one, actually not another one like that. We've got one where we can go one of 2 ways with this problem, so I'll show you 2 different ways to do this. We can either evaluate it separately. We can ask our calculator for the natural log of 5 and get an answer, ask our calculator for the natural log of 7 and get an answer, and then add those 2 numbers together. So let's do that. Natural log, so I'm using control, and now I'm using my ln right above. It's the key to the leftmost in that row. Natural log of 5, we'll get an answer for that. I'll bring up natural log of 7, get an answer for that, and then I'll add those 2 things together. So if I just type a plus and go up and highlight that first result, I'm just trying to be efficient with my calculator here. My result I get is 3.55534. 3.55534, and then I would round that off to the nearest hundredth, come up with 3.56. So that's one way of doing it. I got a number for this one, I got a number for this one, then I added the 2 numbers. But there's another way I could do this. I could rewrite this as the natural log of 5 times 7, or 35, and then I could go to my calculator and I could type natural log of 35, and in one fell swoop I would get the same answer, 3.55534. There's a dot in there, round off appropriately according to the instructions. Again, a 3.56. You get the same answer twice. Move that calculator screen, we'll get some room on the right. To show work for that problem, instead what I can do is I can call that an exponent of 1/2, so that's 5 to the 1/2 power. I could turn that into 1/2 times the natural log of 5, and then that would all be divided by the natural log of 10. And now I can pick up my calculator. That's at least showing some work, showing some knowledge of logs, but I'll make a fraction here. On top of the fraction, I'll put a 0.5 natural log of 5. On the bottom of the fraction, I'll do a natural log of 10. And hit the enter key. We'll get a 0.3494, rounding that off to the nearest hundredth. 3494. If I've got to round that off to hundredths, I'm going to end up with a 0.35. On the last page, I believe this is the last page. Let me just check. Yes, it is, and then I've got homework answers coming up for you. Okay, on the last page here, for each given log, find the anti-log. Well, we're looking for the argument here. There's an x in that position, so it should be fairly obvious what you want to do. Remember that the base of this log is an e, so we're going to take an e, raise it to this exponent, and pick up the calculator, type it in carefully. Your anti-log is right under the natural log. You'd use that e to the x. You pull that up on your calculator. Just hit e to the x all by itself. Don't need the control. You don't want the control. And once you do that, you can type in you can type in e to the x, and you'll see that it'll automatically bring up an open exponent for you. You can put your 2.2030 in there. Hit the enter key, and again, we're dealing with irrational numbers. 9.0521. Round it off to how many decimal? Oh, 4 decimal places, so I better go grab the next one. So the next one is a 2, and when I round off, I just get 9.0521. We got another one of those down here where we need to come up with replacements, and we've got the natural log of 4, and I'm given replacements for natural log of 2 and natural log of 3. So somehow I need to write natural log of 4 in terms of natural log 2 and natural log 3, so I'll turn it into natural log of 2 times 2, which turns into natural log of 2 plus natural log of 2. My pen is not functioning the way I would like it to. And then now I can have replacements for natural log of 2 turns into an x. The other natural log of 2 turns into an x. I had a plus in the middle, so my answer here becomes 2x. Same thing on this next problem here, and this last one, find the value of x to the nearest thousandth. Well, for that one, you can just turn that around into logarithmic form. Natural log, it's a base e, and we don't have to write that, of 35 is equal to x, and you'll pick up your calculator, type this in, and round off your answer as appropriate. Finally, I'll show you the answers for the homework 10.3.